Hi, everybody. We're coming back. We're continuing polynomial inequalities, and we're going to look at one more example in detail. This is an example of a polynomial inequality, and the instructions say solve the following inequality: x to the fourth minus x squared is greater than 5 times x cubed minus x. Now, first, notice this is an inequality. It's a greater than, not a greater than or equal. That still counts. Secondly, notice that the left-hand side is a polynomial, x to the 4 minus x squared. It's a polynomial of degree 4. And on the right-hand side, 5 times x cubed minus x, this is a polynomial of degree 3. Okay, how do we go about solving this? Here's what we're going to do first. So step 1. Let's move everything to one side. And we'll do a little bit of simplification in the process. So what are we going to do? We're going to, for starters, I'm going to distribute the 5 through here, and then I will subtract all of these and move them to the other side of my equation. So that's my 2 steps. Step 1. Distributing, we get 5x cubed minus 5x. And then what am I going to do? I'm going to subtract 5x cubed and add 5x on both sides. And we end up with x to the 4 minus 5x cubed minus x squared plus 5x. And that is all greater than 0. So this is sort of the version of this problem I'm going to work with. It helps in these problems. It's easy to make it so that they always have a 0 on one side. You can just subtract everything off. And then in terms of thinking through the rest of the process, that can make things simpler because you just have a single function to deal with, the polynomial on the left side, and we want to know when it's positive, when it's negative. In this case, we want to know when it's greater than 0, strictly when it's positive, not when it's negative, not when it's equal to 0. Okay. However, the steps that we're going to go through are the same steps that we did in the previous example, and those steps go like this. So let's call it step 2. Set the left-hand side, LHS just means left-hand side, equal to 0. Now, you might be wondering, since there's no greater than or equal to sign, why do we set it equal to 0? And the idea is that this function on the left, x to the 4th minus 5x cubed minus x squared plus 5x, sometimes that thing is going to be positive, which is what we want. Sometimes it's going to be negative, which we don't want. And then in between those, it's going to have to cross the x-axis, and those are the places where it equals 0. And it's those crossing points that we're finding now. This is why we set it equal to 0. We just need to make sure when we set it equal to 0 and solve, we're going to find numbers for x that when we plug them in here, they make this whole thing equal 0. And since this is only asking for numbers that are where it's greater than 0, we're not going to include those numbers in our answer. That's going to correspond somehow to having round parentheses instead of square ones. Okay, so let's set the left-hand side equal to 0. That is x to the 4th minus 5x cubed minus x squared plus 5x equal 0. Now,